Okay, we left off with just a couple more histology things to mention, spongy bone and bone marrow, and then we'll go into ossification in this video. So spongy bone is called that for its sponge-like appearance. The slivers of bone are called spicules. The thin plates are called trabeculae, and the spaces are filled with red bone marrow. It's got a very few osteons, no central canals, because all the osteocytes are close to the bone marrow, and it does provide strength along the lines of stress. And we'll see those in this image. So it shows where the trabeculae, those plates are forming along those lines of stress. But overall, you see the spongy bone in the epiphysis, and it is covered with compact bone. The bone marrow is the soft tissue that's in that medullary cavity or marrow cavity of a long bone. It's also in the small spaces of the trabeculae in the spongy bone that we just talked about. The red marrow is what is producing blood cells, and the yellow marrow is found in adults, and that is what most red marrow will turn into when it is no longer producing blood cells. So this kind of gives you a visual of which bones are actually producing red blood cells, which bones have red marrow. All bones in children and in adults, the ones that are in red in this picture. And then the yellow marrow is everywhere else because it has turned from red to yellow marrow and no longer produces blood. Okay, so let's get into ossification, which is the formation of bone. Just realize I think that these slides get a little detailed and I don't want you to get lost anywhere. There'll be a nice overall visual at the end of this video to kind of get your bearings and review. So here we go. In the fetus and in the infant, we'll see bone developing by two processes: intramembranous ossification and endochondral ossification. So let's talk about intramembranous first. This is the type of ossification producing the flat bones of the skull and the clavicle. They develop within a fibrous sheet, which is similar to the dermis of the skin. This is where I think it gets confusing. They start calling embryonic connective tissue mesenchyme, which is what it's called, but let's just call it embryonic connective tissue because we know what all of those words mean. So this connective tissue condenses into a layer of soft tissue with a lot of capillaries, and then those cells differentiate into osteogenic cells. So here's a picture. On the next slide, those osteogenic cells then differentiate into osteoblasts, the same kind of pathway that we looked at in the previous video. And then the trabeculae get thicker, and then that calcium phosphate is what gets deposited in the matrix to make it strong. And then the osteoblasts are trapped in the matrix, so they then sit there and become osteocytes. Let's take a look at what that looks like. So again, the mesenchymal cells just means the embryonic connective tissue, and there's lots of blood capillaries in there, and then they deposit that calcium phosphate, and then by picture 3, it looks more like bone. Then we see the osteoblasts and the osteocytes that are trapped in there, and then finally the surface of the bone gets filled in, converting from spongy bone to compact bone, but then the spongy bone is still in that middle layer. So again, this is what we see producing flat bones of the skull and the clavicle in fetus or infants. Okay, so most of our bone is produced by endochondral ossification, and this is where bone is developing from cartilage. It happens starting in the 6th fetal week and then ends in your 20s, 20 years old. So most bones develop by this process. So mesenchyme, which remember is still that embryonic connective tissue, and develops into hyaline cartilage, and that happens where the bone is going to be in the future. So it happens in the correct location. And so the perichondrium develops into the periosteum. And so here again we see cartilage has chondrocytes. Those are the cells in the cartilage, and we know that in the cartilage, there's chondrocytes and the matrix. And so this matrix is what ossifies. That's what turns into bone. It blocks the nutrients from reaching the cells, and then they die. And so as those cells die, their lacuna merge into a cavity, and that is what becomes the middle primary ossification center. Now, I feel like that's a weird term, but we're going to see a picture here in just a minute. And those blood vessels are able to penetrate and get into the primary ossification center, and that makes the primary marrow cavity. And this is what's going to form the blood and stem cells in that medullary cavity in the middle of a long bone. So here, I think the pictures are so much easier to follow than the text. So let's take a closer look at this. So it's the kind of blob is that cartilage, and the chondrocytes are the cells inside the cartilage. And it's talking about that the middle, that primary ossification center, is where the cavity is going to develop. And then on the next slide, we're going to get into the secondary ossification center. And that's going to be happening at the distal epiphysis, and we're going to see how that occurs. So stem cells give rise to osteoblasts and then osteoclasts, which we've already talked about in the previous video. Those osteoblasts line the cavity, help deposit tissue to make it calcified. And then that cartilage, as it dies, it progresses towards the ends, kind of pushing it towards each end. So the secondary ossification center is formed by those large chondrocytes and the death in the epiphysis. So it's going to happen basically as the same process, but it's making a little smaller secondary marrow cavity, and it's happening in the epiphysis. And this is where we're going to see the growth. So again, I feel like the picture is so much easier to follow. So number 4 is showing a bone at birth. We have a large primary cavity in the middle, and then the appearance of a smaller secondary cavity at the epiphysis. And that's where we're going to see later the epiphyseal plate. This shows secondary ossification centers or secondary cavities at both ends. We're going to see the growth happen. Usually we see it mostly at the distal end, where we see that epiphyseal plate. And then that the number 6 picture shows an adult bone with only one marrow cavity, and then the epiphyseal plate is closed. The growth is complete. So during infancy and childhood, the epiphysis will fill with spongy bone, and then the cartilage is limited to that articular cartilage covering the joint surface and the epiphyseal plate. So the cartilage is separating those two marrow cavities, and the epiphyseal plate is basically the growth zone for bone elongation, so the growth of the bone getting longer. Okay, toward our late teens or early 20s, we're going to see the cartilage that's remaining in the epiphyseal plate is consumed, and so the gap between the epiphysis and the diaphysis is closed, and then those primary and secondary cavities unite into one large cavity, one single cavity, and the bone is done growing in length. Okay, so this is a picture that I like to kind of just recap the whole process of endochondrial ossification. Again, this is the type that most bones are formed by. And so it's showing from hyaline cartilage, that's our first early cartilage model from embryonic connective tissue. The primary ossification center makes one